Hi everybody, my name is Claire and today I will be showing you how to do the AP Calculus AB free response question number 5 from 2004. This question was on the non-calculator portion of the free response section. The graph of the function f shown above consists of a semicircle and 3 line segments. Let g be the function given by g of x equals the integral of f of t with respect to t from -3 to x. Part A. Find g of 0 and g prime of 0. To find g of 0, we take the given g of x function and set x equals to 0. This will give us the integral of f of t with respect to t from -3 to 0. It is important to note the function f of t is simply the graph of f, or the graph given. Because an integral is something that can essentially express an area underneath the curve, g of 0 is found by taking the area underneath the curve of function f from interval of -3 to 0. This shape is a trapezoid. To find the area of this trapezoid, we will multiply 1/2 times the height, which is 3, times the sum of the two bases. The two bases are 1 and 2, which means the area of this shape is 4.5. Thus, g of 0 equals 4.5. To find g prime of 0, we must first know g prime of x. By the second fundamental theorem of calculus, we can conclude that g prime of x equals f of x. Thus, g prime of 0 equals f of 0, which equals 1 by looking at this graph. So f of 0 here is 1. So g prime of 0 is also 1. Part B. Find all values of x in the open interval -5, 4, at which g attains a relative maximum. Justify your answer. To identify relative maximums of the function g, we must observe where the derivative of g switches from positive to negative. From part A, we have concluded that g prime of x equals f of x. Therefore, we can determine the relative maximum of g by observing the given graph of f. The relative maximum of g must be at x equals 3, because x equals 3 is the only place where g prime, or f, changes from positive to negative. This would be a simple justification that would earn you full credit on part B of this FRQ on an AP exam. Part C. Find the absolute minimum value of g on the closed interval -5, 4. Justify your answer. To find the absolute minimum value of a function, we must consider the relative minimums as well as the endpoints, and test these values in function g and compare the resulting values. From the resulting values, the smallest value will be the absolute minimum. Similar to part B, the relative minimum of g can be determined by observing the graph of f, because again, g prime of x equals f of x. The relative minimum of g must be at x equals -4, because x equals -4 is the only place where g prime, or f, changes from negative to positive. Since -5 and 4 are the endpoints and -4 is the x value for the relative minimum of g, we are testing g of -5, g of -4, and g of 4. Again, g of x is given to us, therefore we can write these integrals like so. Now let's do this one by one. To find g of -5, we must first flip the integral and add a negative sign to make the interval from -5 to -3 instead of -3 to -5. Then we can utilize the given graph of f to find g of -5. So I've copied down the graph here roughly so you can see it bigger and closer and see what's happening. Now let's find g of -5. So g of -5 would be the area bound by the x-axis from -5 to -3 of this given graph. And -2 because we had to add a negative sign when we flip the integral. So we can conclude here that g of -5 will equal 0. This is because the area of a shape underneath the x-axis is negative, which means the area from -5, -4 is -1. That also means the area of -4, -3 is 1, and +1 because it is above the x-axis. We add these two values together to get 0, so negative sign here doesn't matter in this case, but later it will. So -1 + 1 is 0, so g of -5 is equal to 0. Now let's find g of -4. So we again flipped the integral and added a negative sign to make the interval from -4 to -3 and not -3 to -4. Now we can use the graph of f to determine g of -4. So g of -4 will be determined by the negative area from -4 to -3 of this graph given. So we concluded from this part that the graph that the area of -4 to -3 is 1. That means g of -4 will equal -1 because we need to count the negative sign here because we flipped the integral. So this integral here is equal to 1. And then we add a negative sign from flipping the integral. So it will be -1, and that means g of -4 is equal to -1. Now, the hardest part, let's find g of 4. We can split this into 4 shapes. So g of 4 will be found by taking the area bound by the x-axis from -3 to 4. So that means g of 4 is basically just the area of this entire shape right here. So let's split this into 4 shapes. I will label it and circle it. So shape 1, these two will be shape 2, shape 3, and shape 4. So from -3 to 0 is a trapezoid. We can find the area of a trapezoid by multiplying 1/2 times the height, which is 3, times the sum of the two bases. The two bases are 2 and 1, which means the area of this trapezoid is 4.5. So this area here is 4.5. Now we can find the area of this sliver right here. So we need to view this as a semicircle subtracted from a rectangle. Now let's find the area of this rectangle. We multiply length times width to find an area of a rectangle. And in this case, it's going to be 1 times 2, which is 2. So the area of this rectangle is 2. Now we have to find the area of the semicircle. We need to recall that the area of a circle is pi r squared. So the area of a semicircle must be pi r squared over 2. So the radius here is going to be 1, which means the area of the semicircle, which is pi r squared over 2, is going to be pi over 2 since the radius is 1. Now to find the area of this part that I'm shading in bound by the x-axis, it's going to be 2, the area of this rectangle, minus the area of the semicircle, which is pi over 2. So this shaded part here is 2 minus pi over 2. Now, we can conclude that the area of the third and fourth shapes will end up being 0 because the area of the third shape here is 0.5 and the area of the fourth shape is -0.5 because it is below the x-axis. Therefore, these two shapes will add up to 0 in area. Now we can find g of 4 by adding all these areas together. So the g of 4 is going to be 4.5, here I'll write it here, 4.5 plus the area of this sliver here, which is 2 minus pi over 2, plus 0, accounting for the area of 3 and 4. So, to simplify, g of 4 is going to be 6.5 minus pi over 2. Now we can finally determine the absolute minimum of g. We observe these 3 values that we have obtained from testing the endpoints and relative minimum. We can then conclude that g of -4 equals -1 is going to be the absolute minimum of g because it is the smallest values out of the values we tested. These 2 values were from the endpoints and this value was from the relative minimum. Part D. Find all values of x in the open interval -5, 4 at which the graph of g has a point of inflection. Points of inflections are determined by observing where the second derivative of a function changes signs. Because g prime of x equals f of x, as we have determined earlier, we can conclude that g double prime equals f prime of x. If we look at the graph of f, we can see that the slope of f changes signs at x equals -3, 1, and 2. Another way of looking at this problem is to see whether the function f is changing from increasing to decreasing or decreasing to increasing. So as we can see, at x equals -3, the graph of f is increasing and then decreasing. At x equals 1, it's decreasing and then increasing. And then at x equals 2, it's increasing and then decreasing. Okay, so now we have solved the problem. Here's a scoring guide for this free response question. You can check yourself after you solve it to see how you did out of 9 points. I made this video with the intent of going more in depth about the concepts of integrals, derivatives, points of inflections, and relative and absolute maximums and minimums. Other sources that are helpful if you need more help on this type of problem are these FRQs right here from these years and numbers. I will also link additional videos from Khan Academy on the topic of maximums and minimums, as well as points of inflections in the down bar. I hope this video was helpful for those of you struggling with this particular problem. Hasta la vista!